Preparing for civil engineering exams is often treated like an endurance marathon, where the goal is simply to outread the competition. But treating your study plan as a test of stamina rather than a structured engineering project leads to exhaustion and failure. The real threat to your long-term study plan isn't the difficulty of the material itself. It is the daily friction of overthinking your schedule, which quickly snowballs into inconsistency. When a routine requires significant willpower to execute every single day, it eventually breaks down under the pressure of the workload. This flowchart breaks down a sustainable study loop into 3 stages. First, start with a concept video to understand the why. Next, move to the standard textbook to acquire technical depth. Finally, apply that knowledge through a test series. Structuring this loop creates a predictable environment for your brain. This creates a mechanical advantage, ensuring that when you sit down to work, your energy is spent on solving equations rather than deciding which task to prioritize. Once your routine is locked in, you have to tackle the technical phase. But diving straight into heavy structural equations without building a mental model first is highly inefficient. You end up memorizing symbols instead of understanding mechanics. Local buckling is like stepping on an empty aluminum can. Under vertical load, the thin wall crumples inward before the can bends. As these crimping zones highlight in red, the downward load vector remains constant. The material hasn't crushed, the hollow geometry simply failed. This is why the order of your study workflow matters. You watch a short concept video to grasp the physical analogy, like the soda can, and only after that clicks do you open your textbook to read the mathematical derivation. This analogy-first approach becomes vital when you reach design philosophies like the working stress method and the limit state method. One relies on safety factors applied to material strength, while the other applies them to both loads and material limits. Without a mental map of how these safety factors are distributed, the conflicting numerical requirements in the codebooks become impossible to track. Anchoring dense structural math to a physical, real-world analogy ensures that your brain has a reliable backup retrieval system. When exam pressure spikes, you won't blank out on an equation because you remember how the structure actually behaves. Structural theory is only half the battle. The other major hurdle is the overwhelm caused by dense industry standards, particularly text-heavy documents like the IS 800-2007 Steel Code. The IS Code Triad framework scans dense text blocks, stripping away contextual noise to leave only a concise list of exam-relevant numerical values. These extracted points then morph into a clear decision tree, quickly categorizing concrete slump tests or IS 712 Lime classifications. This heat map prioritizes soil mechanics. Let's test this. Classify the plotted point on this plasticity chart before the timer ends. We calculate the A-line boundary, 0.73 times liquid limit minus 20. Our point falls above this line, making it a clay soil. Integrating targeted review loops and active recall aligns your preparation with the actual mechanics of the exam. This system prioritizes high-yield data over general reading, ensuring your effort translates directly into marks. This single document consolidates everything we've covered into a 4-quadrant exam master cheat sheet. It maps your daily habit checklist, physical analogies, extracted IS code values, and active revision loop into one cohesive blueprint. Success in these exams is a product of technical strategy. It is built on maintaining a predictable routine and engaging in consistent, evidence-based self-testing. Download this blueprint framework down below and implement the 4-step loop today to take absolute control of your preparation.